Hello, my name is David de Villiers and I'll be presenting to you my final year computer engineering project, Intrusion Detection System to Protect Against Distributed Ransomware. This project is about solving the problem of ransomware. Cryptographic ransomware encrypts a victim's machine and destroys backups, while distributed ransomware spreads across networks, infecting and potentially encrypting multiple devices in that network. The solution to this problem is to develop an intrusion detection system. Ransomware detection is often achieved through behavioral or signature-based detection. The approach taken in this project was to implement anomaly-based detection, specifically implementing an LSTM autoencoder and an isolation forest. Anomaly-based detection is a subclass of behavioral-based detection. This project consists of three main components, which are the endpoint detection and response agent, the EDR server, and the user interface. The EDR agent's main functionalities are to collect and forward Windows event logs, specifically those logged by Sysmon, as well as to isolate and reconnect endpoints when the appropriate command is received from the EDR server. The EDR server is implemented on an embedded device, the Odroid XU4, and its main functionalities are to receive and inspect Windows event logs, perform anomaly detection, and to manage the connectivity of EDR agents when anomaly is detected. Additionally, it will send updates to the user interface. The detection mechanisms implemented is the LSTM autoencoder and an isolation forest. The LSTM autoencoder was applied to process creation events. This was achieved through taking process creation event string data, vectorizing it through a skipgram algorithm similar to fast text and word2vec, the fast text and word2vec algorithms. And this data was fed into an LSTM autoencoder, which attempted to reconstruct the input and get a reconstruction error, which is then used to determine whether an anomaly is present, which might indicate the presence of ransomware on a virtual machine. The isolation forest was applied to file creation events. The isolation forest works on the principle that it is easier to isolate an anomalous data point than it is to isolate a normal data point. And in this case, feature extraction was achieved using the XXHash algorithm. With an anomaly threshold of 0.4, the LSTM autoencoder achieved a true positive rate of 93 to 100%, a false positive rate of 0.8%, which resulted in an overall detection accuracy of 97%. These results were obtained through testing WannaCry, Ryuk, Cerber, and DarkSide ransomware. And Task Manager and the Windows Management Provider service was detected as false positives. The isolation forest initially suffered from a high false positive rate. However, this was improved upon when implementing a frequency-based threshold, meaning that the isolation forest is only applied when receiving more than 7 file creation events from any EDR agent in the virtual machine network. This, with a threshold of 0.55, the isolation forest achieved a detection accuracy of 100%. The mean detection time was 725 milliseconds. The mean isolation time was around 475 milliseconds. And as the network expanded, as the network grew larger, the detection time increased linearly. The average isolation time also increased by 46% to 693 milliseconds. And the EDR agent never used more than 1% of available processing power, and the RAM usage never exceeded 40 megabytes. Thank you. For the next part of the demonstration, I'll be showing my project in action. Alright, so for the next part of the demonstration, I'll be showing my system in action, detecting ransomware and isolating a specific virtual machine. So this is output from a previous run I did, but we can first test the connectivity, show that the system is able to isolate virtual machines from the network. This is the network of 10 connected computers. So I'll be going to server 1, and I will ping the domain controller. You can see it is successful, and I can move back and isolate this. This is the intrusion detection system user interface sitting on, well, it's executing on the Odroid XU4 embedded device. And I can ping it again, the domain controller again, and there's general failure, indicating that isolation is successful. I will reconnect server 1 to the network, and I can execute ransomware. For security precautions, we need to disconnect network adapter 1. This is an adapter that is connected to the host computer. We do not want this ransomware to spread to the external network, so we need to disconnect that. And we need to disable access to the Vagrant shared folder. This is a folder that is shared between the virtual machine and the host computer. We do not want to encrypt any of the data residing on the host computer. So we can see it's not accessible, which is what we want. We can move on to the ransomware folder, and for this demonstration I will be executing WannaCry ransomware. I'll just rename this to WannaCry. Right, you can see it's executing there. The server 1 has been isolated. You can see the LSTM autoencoder has detected the process creation as anomalous, and the isolation forest is detecting WannaCry activity as anomalous as well. We can move back to the server 1, and we can try to ping the domain controller again, and it's general failure. And this shows that the virtual machine has successfully been isolated from the rest of the network. And we can see the virtual machine has been encrypted now. And the isolation forest and the LSTM autoencoder will continue monitoring all virtual machines. We can see the isolation forest is still picking up anomalous activity from WannaCry, and it has been isolated. Thank you for watching this video. If you have any questions, please leave them in the comments below.